Hello everybody, welcome to another C# executable code video. Today we're actually looking at version 2 of the resultant vector calculator video that I posted about a week ago. I've updated it, added some new functionality to it to improve on the original design. So let's talk improvements, because the idea and concept of why I have this remains the same. It's to calculate the addition of one to multiple vectors in 2D, but there were some issues with that version. The lookup table was not big enough, and so specific values could not be precise enough. So sine and cosine of 45 would not give you root 2 over 2, that sort of thing. So in this version, under the 2D stuff, we've actually increased the lookup table size. It also applies to the new version, which has this new version has a 3D calculator, so you can give it 3 vectors, 2 angles, and it would basically allow you to, or each vector would have 2 angles and a magnitude, which will allow you to calculate 3D vectors, which is great. So we have our lookup tables here, lookup for sine and cosine, and our conversion from degrees and radians set up. Basically, the code for this one looks a lot cleaner comparatively to the previous one. It's a lot more professional. I also have some images here in this project to display how this works. So what you're looking at here is what the 2D vector looks like. So this vector, we can call it vector A if you wish, has a magnitude, which is lowercase a, that's the length of this, and it has an angle with respect to the x-axis, particularly due east positive. That is capital A, the ascent angle, theta. When you're calculating a 3D vector, this is what you'll be seeing. So we have vector A, and this is the exact same picture. This left side is the same as this, with the magnitude and the ascent angle. But if you imagine taking this right plane and placing it on top of this image, and then rotating this image to be flat instead of facing you, with the z plus pointing away and the z minus pointing towards you, and the x is overlaid, then this heading angle is the angle with respect to the positive x-axis heading away from you positively, is that angle. So that way you can calculate the length of this in 3D space. You'll have an x, a y, and a z component of this. Now, of course, I have gone ahead and created an executable of this, so we'll just go straight into that. This is it right here, the resultant vector tool. And of course, one to exit will close the whole thing. Good stuff, good stuff. And we also have 2D and 3D calculations. Let's run some 2D vector calculations. So just as with the last video, we have a loop where it'll constantly ask you for vectors until you're done. Let's enter the angle of ascent. This is the same as the angle you were entering for the last one. So let's do 50 degrees. And the vector magnitude, let's do 10 degrees, or 10 meters. And we have another vector we'd like to try. Let's do 120 degrees. This is an angle to the left. This is technically west of north, is what it would be considered. And for the vector's magnitude, let's do 12. Say we have no more vectors to add, and now we're given all the resultant vector components. So we're given the x and y components of each of these two vectors. The first one being 50 degrees means it is moving up and right, so both being positive makes sense. This angle is 120, which means it is moving to the left and up, so negative, positive makes sense. The resultant combination, this vector has a resultant of basically due north, but is moving east of north, and just barely such. With a positive x and positive y, that would make sense, especially with how close it is to due north. It almost has no x at that point. And the resultant magnitude is right here. This is just an addition of these. These basically cancel out. This becomes 18, and the square root of 18 plus that ends up giving you that, so more or less. So let's go ahead and let's try a 3D vector for this next part. So we enter 3 for the 3D calculation. Notice how for this one, it doesn't exit right after you're done with your calculation. This one, I set it to loops constantly, since there's more than just one option. Previously, it was just really annoying to put up with having to reload the tool constantly, so it'll stay open until you press 1 for that segment. So do we have more vectors to add? Yes. First, it wants the angle of ascent. Let's give it the angle of 30 degrees. And the angle of heading, that's your other one, let's give it an angle of, let's do 115, because I like COD zombies. Okay, so this angle will be moving away from you. It'll be moving away from you and up, if that makes any sense at all. If you remember the image, it will be moving to the on the left side of one angle. So enter the magnitude of this vector, will enter 20. And we get all of the components of these. Do we have more vectors? Then we say yes, and now we give it another ascent angle. Let's give it the angle of 60. And an angle of heading, let's give it an angle of 30. With a vector magnitude, let's say 15. And say we have no more vectors to add. Here's all of our values. So we ended up with an ascent direction of moving top right and quadrant. This is a quadrant 1 ascent. So quadrant 1 between x, y. And this will be quadrant 1 between x and z, with a resultant of 42.442. And then we just hit 1 to exit, and that's that. I hope you guys enjoyed the improvements to this. I will see you guys in the next video. Peace.